Hi, in today's video, we will be discussing about the problem that is given here. Notice that this problem can be solved analytically. However, adopting a combinatorial approach not only eases computations, but it also gives us an intuitive idea about how the problem might be modeled to represent a real life scenario. So we have been asked to show that summation k equal to 1 to n choose k times k cube is equal to n square times n plus 3 times 2 power n minus 3. So we can assume that there are n people out of whom we need to select a committee and of the committee members we need to select a president, a chairman and a vice chairman, say. Note that the size of the committee can be any number between 1 and n, any positive integer between 1 and n, and the special positions, the president, chairman, and vice chairman, may or may not be the same person. So, how do we count? One way of counting the number of ways in which the above can be achieved is to first choose a committee of k members and then select the chairman, vice chairman, and president from among them. So say we choose a committee of k members, we can do that in k ways, in n choose k ways, and from among the k chosen members, we can select the president, chairman, and vice chairman in k cube ways, because all of them might be the same person. There is no restriction on that. So the size of the committee ranges from 1 to n. So the number of ways to do so is summation k equal to 1 to n choose k times k cube. On the other hand, we can count the number of ways in using another approach. First, we select the president, chairman, and vice chairman, and then we select the other committee members. So how do we do that? Three cases arise. Case 1, all the position holders are the same person. So in that case, we can choose that person in n ways, and for the remaining n minus 1 people, they might either be in the committee or might not be. So the number of ways in which the committee can be formed with the position holders is n times 2 power n minus 1. For the second case, two of the position holders are the same person, and the other person is a different person. So we first have to choose the two positions which are held by the same person. So that can be done in 3C2 ways. Now we have to choose the person who holds that position. That can be done in n ways. Next, we choose the person who holds the remaining position. That can be done in n minus 1 ways. As for the remaining n minus 2 people, they can either be in the committee or not. So the number of ways in which the committee can be formed is 3C2 times n minus 1 times 2 power n minus 2. As for the third case, all of the position holders are different. So the people for the three positions can be chosen in n times n minus 1 times n minus 2 ways. And the remaining people, remaining n minus 3 people may either be in the committee or not. So that accounts for 2 power n minus 3 multiplied with n times n minus 1 times n minus 2. Now we add these up. So this gives us n times 2 power n minus 3, which is common. Then we have 4 plus 6 times n minus 1 plus n times n minus 1 times n minus 2. Now note that we have been counting the same thing in two different ways. So the number of ways that this can be achieved is equal in both the cases, which leads us to conclude the following equality. Summation k equal to 1 to n choose k times k cube is equal to n square times n plus 3 times 2 power n minus 3. And we are done. So this was an example in which counting in two ways can be used to solve analytical problems in a more elegant way. So hope you guys enjoyed this video, and I am looking forward to meet you all in the workshop. Thank you.